And we're back. Okay, so this is part 3, as I need to finish off the stuff here. So exothermic energy and endothermic. Now there's a couple of ways to look at this. Exothermic, thermic, think about heat. Exo meaning going out, like Exodus, like the book of the Bible. Okay, you can look at exhale. Okay, we can talk about excite or exit. I am so out of here. So in exothermic, you've got energy that's being released to the surroundings. Okay, that's exothermic. Okay, so explosions, hand warmers are obvious examples. But how is freezing ice cubes an example of exothermic? Well, the idea is, how does water freeze? It has to lose its heat energy, doesn't it? That means the heat energy exits the water, and thus the water becomes frozen, it becomes solid. Okay, so that's what you'd have. Endothermic, on the other hand, it's absorbing. Endo, going inside, like endoskeleton in baby bio. Right. We as humans, we are designed with an endoskeleton, right? Whereas bugs have an exoskeleton. So for us, endothermic, it absorbs energy from the surroundings. What's the point of putting ice in your soda? To make them cold. How does it do that? It sucks the heat out of the soda. It absorbs it out of the soda and makes it cold. Okay? On the other hand, here, what happens when you end up injuring yourself? You put an ice pack. What's the point of the ice pack? Soaks up the heat energy from that immediate area to lower inflammation. Right? Because your body wants to respond to it immediately. And that's how our bodies are designed. Okay? Let's move on. So temperature scales used most often in chemistry, we'll look at Celsius and we'll look at Kelvin. Okay? So Celsius and Kelvin scale, it's our basic metric unit of temperature, and we're going to use them at Kelvin later on. The third law of thermodynamics, it's impossible to reach absolute zero. We've been very, very close. We've gotten to 0 Kelvin is our goal of absolute zero. We've gotten to 500 times 10 to the minus 9th. So move the decimal over 9 places to the left. That's how close we have gotten. The weird part about this is, with the material of sodium, potassium, it starts to behave in weird ways. We have not understood it. So we haven't gotten things down to absolute zero, okay? Even my album sales. Calories and kilocalories, okay. Calories and kilocalories, they're units of energy. Calorie is how much heat is needed to change the temperature of 1 gram of water 1 degree Celsius. The kilocalorie is 1,000 of those small c calories. And the kilocalorie is really what you see on food packages, soda, and whatnot, because they're big C calories. Okay? So, with that, we have the states of matter, the kinetic-molecular theory. Okay, as we're winding down, we have our objectives. Okay, we're going to look at the 4 states of matter and material and how the particles behave. Okay, so here we go. If it's solid, you have particle attractive forces are greater than the kinetic energy between the particles. Okay, so particles are in relatively fixed positions with certain distances between them. Okay. When we look at liquid, the particles, particles are partially overcome the attractive forces between them. Particles can move about, but they still remain kind of close to each other. That's what a liquid does. That's how the particles behave in any liquid. Okay? Now, on the other hand, if the particles are completely overcome, the attractive forces between them, it's like, I am out of here. Okay? So what happens is those particles, they have a lot of kinetic energy and they're running around. They're also highly compressible when you look at a gas. Okay? There is no definite shape with gases. Whereas you have a shape with a liquid, you have a shape with a solid. Okay? Plasma. Woo! Man. All the electrons are stripped away from the atom. It forms a positive ion. Okay? It is the most common state of matter in the visible universe, but not here on the planet. But this is what we're seeing out there in the nighttime skies, guys. And then the changes of common states of matter, you guys are pretty familiar with the changes. Okay? Sublimation, deposition, and vaporization are the ones that probably, and condensation, those are probably the ones that, people would need to be familiar with. Okay? And with that, guys, this is chapter 2 in a nutshell in 3 parts. Okay? All right. I'm Obi-Wan Kenobi, and let's face it, you're not. This concludes chapter 2. Adios, muchachos.